Hello and welcome to our 18th session, and in this session we are going to discuss about Dockers. Now in our previous session we installed Ollama and we were able to create simple queries. But if you want a realistic chat GPT like user interface, we have to rely on another tool called as Open WebUI, and we are going to install this Open WebUI in D drive. Then we have to make use of a new type of installation system called as Dockers. So let us first understand what is a Docker. A developer writes a piece of code on their laptop and it runs flawlessly. But when they hand over that same code to the testing team or upload it to a live production server, it immediately crashes. The failure usually stems from an environment mismatch. The developer's laptop has a specific set of background libraries, language versions, and configuration files that the production server is missing. Without these exact ingredients, the application cannot function. For decades, the industry relied on virtual machines to solve this problem by isolating every application within its own simulated computer. To run a single app, the server boots an entire operating system like Windows or Linux on top of a simulated hardware. To run 3 apps, you must run 3 full heavy operating systems simultaneously. This architecture is incredibly resource intensive. Most of the server's RAM and CPU power is wasted keeping these redundant operating systems alive rather than actually running the code the developer wrote. Tech teams were forced into a compromise. They could deal with the constant breaks of inconsistent environments, or they could accept the massive hardware costs and slow performance of virtual machines. Docker replaces that hardware simulation with a standardized digital shipping container. It packages the application code along with its entire environment into a single portable unit. This process starts with the Dockerfile. It is a plain text recipe that lists every single file, tool, and settings the software needs to execute. The Docker file tells the system which base environment to start with, which specific dependencies to download, and exactly where the source code should live. It eliminates the ambiguity of manual server setup. When Docker reads that file, it bakes it into an image. This is an unchangeable blueprint constructed through a union file system. It creates the environment by stacking individual layers, OS files, libraries, and app code into one block. Docker caches layers individually. If code changes, only the top layer updates. Heavy base layers remain frozen, rebuilding the application in seconds. Because this image is a frozen snapshot, it carries the exact required environment wherever it goes. The version used by the developer is identical to the one that runs on the server. While the image acts as a static frozen blueprint, the real work only happens when that blueprint is finally activated. Once the image is turned on, it becomes a container. Docker adds a thin writable layer on top of the image, giving the application the memory and space it needs to run processes and handle data. Unlike a virtual machine, a container doesn't boot its own operating system. Instead, every container on the machine shares the host kernel. This allows the system to run dozens of apps without the overhead of multiple OS stacks. Docker maintains security through features like namespaces and C groups. These partition the system resources, limiting what the container can see and ensuring apps cannot interfere. It works like an apartment building. All the residents share the same underlying foundation and plumbing, but every unit is behind a separate locked door. Because they don't have to wait for an operating system to boot, containers launch almost instantly. This efficiency means a single server can support a much higher density of applications than traditional methods allowed. This design provides the secure isolation of a virtual machine but removes the hardware redundancy that previously limited server performance. Container Dockers are designed to be entirely ephemeral. When the main process finishes or the application is shut down, the container and its internal data vanish. To prevent data loss, Docker uses volumes. These act as permanent storage lockers that exist independently of the container. Databases and logs are stored here, so the information survives even if the container itself is deleted. This modularity allows different containers to work together. A front-end service can talk to a back-end service over an isolated internal network, creating a complex system out of simple individual parts. When an app is ready for the real world, the developer pushes the finished image to an online registry. From there, the image can be pulled and run on any server in seconds. It will behave exactly the same way on a personal laptop as it does in a massive cloud cluster. By merging the application with its dependencies, Docker standardized software delivery. It ensured that the package verified in testing remains identical when deployed to a global network of servers, allowing engineers to build and scale systems with predictable results. Now, before we start installing the Docker, I will come into Windows and open my File Explorer. Come to D Drive AI Studio. I am going to right click and create a new folder, and I am going to call this as Docker Data. I will open my browser. In the search, I will type Docker Desktop and press enter. The very first link here, docker.com product Docker Desktop. Click on this first link here, and here you have an option download Docker Desktop. I am going to install it for download for Windows, and we have to select this AMD 64. Click on this. If it shows a warning, click on download unverified file. Come to the downloads folder. Select this Docker Desktop install.installer. Double click to start its installation. You have the configuration. You have used WSL2 instead of Hyper-V. I have enabled it. Allow Windows containers to be used with this installation. I will enable this. With all the three enabled, I click OK. You can see the files are getting unpacked and the installation process has started. Once the installation is complete, you have the option close and log out. After the system logs out and logs in, you have the Docker Desktop shortcut on the desktop. Double click to open this. It will ask for the Docker subscription service agreement. Click on accept. It is asking me to create an account in the Docker. Click on create account. I will choose personal. Enter the email, username, password, and click on sign up. You will now receive a mail in your mailbox from the Docker, and you will have the code here. You can copy the code here, come back and paste the code, and then press verify. Your verification is successful. Click on proceed to sign in. You can enter username or email here. Click continue. Enter the password. Click continue. Click here open dockerdesktop.exe, and you are logged in with your user account. I will come here into the settings. Come into the resources, and in advanced, you have disk image location. Click here, browse, come to your D drive, AI Studio. We had created this folder called Docker data. Select this folder and click on apply and restart. It is asking you to move the disk image. Click yes, move it, and this setting will now be applied and Docker will be restarted. Safer side, you can close Docker desktop, come into the Windows menu and restart the machine. After restart, launch Docker desktop. Right now, no container is running here. Come back to setting, resources, cross-check. Your DAI Studio Docker data is the location to store all your disk images. Click here, close. Now, most of these Docker images are present on GitHub. We are going to pull a disk image from the GitHub and we are going to install and run it. The very first disk image we are going to pull is Open WebUI. What is this Open WebUI and how to do installation with Docker? We are going to discuss it in our next session.